So now that we have our whole unit circle filled in, we want to think about filling in the coordinate points. So the coordinate points actually come from special right triangles. So thinking back to geometry, there are two special right triangles. One is the 30, 60, 90 triangle. So I'm going to try that right over here. So 30, 60, and then 90 is the little box in the corner. And then our other triangle is the 45, 45, 90. Oops. So both of these angles are 45 degrees, then we have 90. So for these two triangles, each of their sides follows a pattern. So like, for example, I'll go with this triangle right here, the 45, 45, 90. These two sides are always going to be the same value. So I'm just going to call those sides X. So if this side is, let's say, 2, then this side has to be 2. So they both have to be the same. This side is always whatever this number is multiplied by square root 2. So x times the square root of 2. So if this side was 2 and this side was 2, this would be 2 times the square root of 2. And it always follows that pattern. So now for the 30, 60, 90 triangle, the pattern is the side across from the 90-degree angle. So whatever this side may be, we can call it x. The side across from the 30-degree angle is 1/2 times x. And the side across from the 60-degree angle is the square root of 3 over 2 times x. Now, when you saw this in geometry, you may have seen these ratios as different, like this is 2x. I've written it so that it's going to make it easier for us to get these points from this triangle. So let's say that this side is x. So that means whatever this is, let's say this is 10. That means the side across from 30 is half of 10, so 5. And then the side across from 60, this one is square root of 3 times 2 times 10. So 10 times the square root of 3 over 2. It would be that number. So putting that in this perspective here. So if we made, I'm just going to do a little dotted line going down. We can actually create a 30, 60, 90 triangle right on our unit circle. So you don't have to do this on your unit circle. I want you to just watch. So this would be the 90 degrees. We don't know what this length is. We don't know what this length is. But this length and this length are going to represent my x and y. So whatever this side of the triangle is, so this side right here, that would represent my x value in the coordinate. And this would represent my y value, this side, because x is always a horizontal distance and y is always a vertical distance. Now, we do know one value on this triangle, and it is this side right here, the hypotenuse, because the hypotenuse goes from the center to the outside of the circle. So that means it is equal to the radius. If you remember from the last notes video, unit circle has a radius of 1. So that means that this length equals 1. So if x equals 1, that means that this side is square root of 3 times square root of 3 over 2 times 1. So just square root of 3 over 2, that would be my x. And y would be 1/2 times 1, which is just 1/2. So that is how you can logically get to the points. So when people say you have to memorize the unit circle, you actually don't. There's a way to think it through. And I wanted to show you guys this. But keep in mind, once you create the unit circle, it's never going to change. So you don't actually have to go through this whole process. I know this is a lot of math coming at you here, but all you need to know, if this confuses you, that 30 degrees in pi over 6, that angle measure has a coordinate point of square root 3 over 2 and 1/2. Now the next one, so 60 degrees, what if we redrew this triangle? So now instead of the 30 degrees being down here, it was the 60 degrees. This is actually going to be shorter. Okay, so 60. And now 30 is up here. So now instead of 1/2 being on this side, 1/2 x flips down here and square root 3 over 2x flips up here. And then the hypotenuse is x. So once again, if we made this triangle, this is 90. Now my x value is the one at the bottom, so 1/2 times x. My hypotenuse is still 1. So that would mean my x value is 1/2. And my y value is square root 3 over 2. We can do the same thing here for 45, 45, 90. So x, and then this is x times the square root of 2. So if we think about this as the triangle, it's my 90 degrees. We know that x times the square root of 2, this equals 1. The hypotenuse is equal to 1. So what would my two sides be equal to? They would be equal to 1 over the square root of 2. So how did I find that? Well, right now, if I wanted to solve for x, because that's what this side equals, I would divide by the square root of 2 on both sides. So that's how I get x is 1 over square root of 2. Now, I'm going to do this over here so I have more room. In math, it is not simplest form to have a square root in the denominator, so we have to multiply the top and bottom by square root 2. So we get square root 2 over the square root of 4. I'm going to have myself. And the square root of 4 is 2. So we get square root of 2 over 2. So once again, I need to get this out of the denominator. I multiply top and bottom by the square root of 2. 1 times square root of 2 is square root of 2. These multiplied get square root of 4, which is equal to just 2. So that was the point. We wanted to get the square root out of the denominator. So that means that both x and y are square root of 2, because this side represents x and this side represents y, but they're both the same. So that is how you get these three coordinate points. So notice the special right triangles include 30, 60 degrees, and 45 degrees. So that is the reason why these are the three angles we have. All right, so before I move on and do all of the other coordinates, let's do these ones on the ends here. So knowing what we know about our unit circle, this has a radius of 1. So here we're going all the way to 1 on the x-axis, and we're not going up at all, it's saying it's 0. So this point would be 1, 0. This point, now we're not going anywhere on the x-axis, so x is 0, but we're going up to 1 on the y, so this one is 0, 1. To the left, we're not going anywhere on the y, but we're going to negative 1 on the x. So negative 1, 0. And then down here, we're not going anywhere on the x, so 0 is x, and negative 1 is y. Now for all the others, you'll notice I have this positive, negative, positive, negative. So that's talking about the quadrants. So this quadrant here is positive, positive. So both x and y are positive. So if both x and y are positive, you'll notice that's how we got this. Now in this quadrant, the numbers are going to match for each of the colors. So this angle, that is like a pi over 3 radian. That's kind of like how I like to think about it. Whatever the denominator is, those are the ones that match. Is going to have this coordinate point. So 1/2 square root 3 over 2. But in this quadrant, y is positive and x is negative. So when I write 1/2 square root 3 over 2, the x has to be negative and the y has to be positive. So negative 1/2 positive square root 3 over 2. Now for my green angle, I'm going to use the same point, but my x is negative. Negative square root 2 over 2. Positive square root 2 over 2. For my purple, same point, but negative x, positive y. Negative square root 3 over 2, positive 1/2. Now we're going to continue that process down here. So here, my purple angle, or my purple point, goes with this, but now we don't have any positive values. Both x and y are negative. So both points are going to be negative. Once again, the same point, but both negative. Negative square root 3 over 2, negative 1/2. For green, we have square root 2 over 2, square root 2 over 2, and both of them are going to be negative. Negative square root 2 over 2, negative square root 2 over 2. For our red angle, we have 1/2 square root 3 over 2. Both are going to be negative. Negative 1/2 square root 3 over 2. Here we have a red angle again. Now this is the positive x, negative y. So this will be positive 1/2 negative square root 3 over 2. And then for green, positive square root 2 over 2, negative square root 2 over 2. And then for purple, it is positive square root 3 over 2, negative 1/2. And that is how you fill in the unit circle.